Okay guys, this is your review for AP Physics, the kinematics test, or the acceleration test. Number one says a rock is dropped from the top of a tall building and takes 4 seconds to reach the ground. How tall is the building? So we're going to list out our information we know. Time is 4 seconds, but that's all it gives us. Fortunately, we know that this object is in free fall, and it was dropped. So the initial velocity is 0, and the acceleration is negative 10 meters per second squared. Okay? So that is the information we have. We're trying to figure out how tall the building is, so we're looking for the height. But keep in mind the height will be the change in position, right? If it falls, it's going to be the change in position and is going to be the height. So we're looking for x. That's what we're looking for. Okay, so we've got x, we've got a, we got VIT. So we're going to use the x equals formula, 1/2 AT squared plus V naught T. Forgive me, I used the one that we use in regular physics. It should be V naught T. So we've got x is equal to 1/2 times negative 10 times 4 squared plus 0 times 4. And we end up getting x is equal to 80 meters. It's negative 80 meters because it fell 80 meters, but the height would just be 80 meters. Okay? On the test, if you put negative 80, I don't think we'll count off. I won't count off. But anyway, I can't speak if you're watching this from another teacher. 2A. 2A, okay, so 2A is talking about the graph. So the key thing you need to note is that you're looking for average velocity. Average velocity is the change in position over the change in time. Now, some of you might go, well, isn't it also final velocity plus initial velocity over 2? That's true, except it only works, that part only works when you're accelerating constantly. Note that we're not accelerating constantly here. We are only accelerating constantly for the first 4 seconds. So the V naught plus VI over 2 only works for those first 4 seconds. So what we have to do is we have to find the area under the curve, the area under the triangle bit is 16, and the area under the rectangle bit is 32. And so we get a change in position of 32 plus 16, which would be 48, and a time of 8 seconds. So the average velocity would be 6 meters per second. Okay, average velocity again, change in distance over change in time. The important thing there, the reason we're showing you that is to remember that the area under the curve is the change, is the change in position. Okay. Also remember that this is part B, that the acceleration is the slope of a velocity versus time graph. So on this velocity versus time graph, it's asking us to find the acceleration for the first 4 seconds. So you can do this one of two ways. You can either look and do, VI equals 0, VF after 4 seconds is 8, and T is 4 seconds. And you can use your A equals VF minus VI over T formula to find it, which is fine. You would get A is equal to 8 minus 0 over 4, and A would be equal to 2 meters per second. Nothing's wrong with that. That's the correct answer. But you could also use this formula, or not formula, but this statement, acceleration is equal to the slope of a velocity versus time graph of a V versus T graph. And you could find the slope of that line and you would get the same answer. Okay, so if we got the slope of that line, we would do 8 minus 0 over 4 minus 0, and we would get 2 meters per second squared. Alright, that's number 2. Number 3, this was the dot problem. I think it gives in a lot of people trouble because you didn't know to measure the distance. So you do have to measure the distance. So 2 things. Number 1, it tells us that there are 20 flashes per second. And how many flashes do we have here? Well, we know we start at 0 because that first flash is when time started moving for us. And then we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I apologize, this isn't perfect in terms of spacing, but we got 10 flashes. And that should be at 6 seconds. So we have 10 flashes, and they occurred at a rate of 20 flashes per second. So if we had 10 flashes, we have time equal to 0.5 seconds. Okay, what else do we have? Well, we measure the distance. If you measure the distance, you should get somewhere, I mean, it depends on how good you are at measuring, but you should get about 14.7 centimeters per second, centimeters. And then it tells you it's a 10 to 1 factor. So what that means is that the value here is 10 times what the value should be. Okay? So it should be 147 centimeters or 1.47 meters. Okay? So there you go. We got 1.47 meters for distance. And again, the reason we did this is because it was a 10 to 1 factor. Okay? The next step is to, let's see. Yes, the next step is to figure out the acceleration, because that's what it asks us to do. What's the acceleration of this object? Well, we do have to note something else. The initial velocity here is probably 0 because it doesn't look like it's moving very much at first, and that's a safe assumption that we can make. And so if we're looking for acceleration, we're going to use the x equals 1/2 at squared formula plus v naught t. And we're going to go 1.47 equals 1/2 a times 0.5 squared plus 0 times 0.5. And if we solve for this, solve for a, you should get 11.76 meters per second squared equals a. And if you're off by just a little bit, it's not a huge deal. All right, so it's not like you're going to get the problem wrong if you're off by like 0.2 or something like that. It should be okay. All right. It also asks us to find the average velocity. So the average velocity is change in distance over change in time. So we're going to assume both things started at 0. So we just do average velocity equals 1.47 over 0.5, and we get the average velocity equals 2.94 meters per second. Okay, so there's your average velocity. That's how you calculate it. And there is your acceleration and how you calculate it. All right, next up, number 4. Number 4 is the ruler drop problem. So we know that the kid drops at 20 centimeters. First step, every time it's in centimeters, you got to get it to meters. So distance is equal to 0.2 meters. We also know it's been free fall, so the acceleration is negative 10. Also, we know it fell 0.2 meters, so that number should be negative. And since it was dropped, the initial velocity is 0. And we're looking for time. So, I should change this to x, I'm sorry. There we go, x. So, we know this information. So what we're going to do is look for the formula that will work, and the formula that will work is x is equal to 1/2 at squared plus v naught t. We know that's 0, so we're left with 0.2, negative 0.2, equals 1/2 times negative 10 times t squared, and we would get 0.0, you divide by, so we get negative 0.2 equals negative 5 t squared, divided by negative 5, and we would get positive 0.04 equals t squared, and then we square root both sides, and we get 0.2 seconds is equal to t. Okay, so you should get 0.2 seconds equals t. And last but not least, we have number 5. So on number 5, on this one, the ball is going up. It got shot up with a velocity of 80 meters per second. So, or sorry, that's 60 meters per second. So the initial velocity is 60 meters per second. We know acceleration is negative 10 meters per second squared. And the question A asks us what is the speed after 2 seconds? So we're looking for VF, and for part A we have T. T is 2 seconds. So using the information I've got, I'm going to use A is equal to VF minus VI over T. Okay, so we got negative 10 equals VF minus 60 over 2. Negative 20 equals VF minus 60. Add 60 over, and we get 40 meters per second equals VF. Question B says, where is the ball after 8 seconds? Where is a position formula. So we're going to use x equals 1/2 at squared plus v naught t. Notice that we have a v naught. So we have a v naught, that should be v naught, sorry. We have a v naught, so we do have to plug in that number. So x is equal to 1/2 times negative 10 times 8 squared plus 60 times 8. If we solve, we get negative 320 plus 480, and x is equal to 160 meters. And the last question says, how high does the ball go? So the key thing there to remember is that at the top, the initial velocity, or that velocity up there at the top, is 0, and the velocity down here is 60. So if we can find the time there, we can figure out how high it went. So let's figure out how long it was in the air. And we can do that by using the A equals VF minus VI over T. Whoops, that's supposed to be a T. And so we go negative 10 equals 0, the velocity up here at the top, minus 60 over T. And if we solve for T, we get T equals 6 seconds. So now I want to know the position of that ball at 6 seconds. So we do x is equal to 1/2 times negative 10 times 6 squared plus 60 times 6. And I get x is equal to 180, negative 180 plus 360. And I get x is equal to 180 meters. All right, that finishes up the review. Keep in mind you need to know the formulas. These are the formulas one last time so that you've got them. A is equal to VF minus V, oh, my bad, sorry. A is equal to V minus V naught over T. X is equal to 1/2 AT squared plus V naught T. And VF squared, not VF squared, V squared equals V naught squared plus 2AD. And then last is the V average formula, and that is V plus V naught over 2. That's good, remember, when it's constant acceleration, not always, but only for constant acceleration. Only for constant A. And then this one's good all the time. Delta x over delta t. Okay? And you only have to use one pair at a time. You can use V average equals that, equals this, or V average equals this, or set V plus V naught over 2 equal to delta x over delta t. Alright? I wish you the best of luck on the test tomorrow. Make sure you memorize these formulas. You will need them on the test. 100% chance. Alright? Have a good night. Good luck studying. And if you wake up at 5 a.m. To go to the pep rally, then you're a better person than I am.